Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us move to the next paragraph. Paragraph 2, question number 35. 2017 JEE Advanced Physics paper. Students, this is the second paragraph and it contains two questions. The first question we'll solve now. After that we'll solve the next question. 1 12s circular ring. You can see that this is a circular ring. 1 12 ring, this rotates like that. Just 12 it. Ring of mass m and radius r. This is a ring of mass m and radius is r. This is a mass m and having radius r. This is for the ring. Near the tip of one's finger, just like that, it rotates at the tip of the finger. So when you rotate at the tip of the finger, it performs a circular motion, as well as the ring also performs a circular motion. In the process, the finger never loses contact with the inner ring of the ring. So the ring and the finger never loses contact. The ring is the finger which tilts the ring, and the ring always remains in contact with the finger. The finger traces out the surface of a cone. You can see that if the finger moves like that, it traces a cone. You can see with the dotted line, the finger is actually tracing a cone. The radius of the path traced out by the point, this point will trace a path like that, circular path. Point where the ring and the finger is in contact is R. That means the tip of the finger moves in a circle of radius small r, which is represented here. So this is how this goes. This is the radius of the tip of this finger. The finger rotates with an angular velocity omega naught. So this is actually rotating with omega naught. Okay. The rotating ring rolls. The ring is actually rolling on the finger without slipping. It's a case of pure rolling on the outside of a smaller circle. So this ring is actually rolling on this smaller circle, just like that. It's rolling. Described by a point where the ring and the finger is in contact. So this is the point about which the rolling is taking place. Just like if you have a surface and there is a, suppose a disc over here, and it is rolling, so it is translating and rotating. So this is the point about which this will rotate or roll about this point. Similarly, this ring is rolling about this point. So this point is known as the instantaneous axis of rotation. Here also we can consider this as the instantaneous axis of rotation. Where the ring is in contact with the finger, the coefficient of friction between the ring and the finger is mu. The coefficient of friction is mu, and the acceleration due to gravity is z. So we have mass m of the ring. For the ring we have mass m, radius r. For the finger we have it is rotating with radius small r. The coefficient of friction is mu. Acceleration due to gravity is small g. These are the specification, and the finger is rotating with omega naught. These are the things given. Now we have to find the total kinetic energy of the ring. Total kinetic energy of the ring we have to find, because the ring is rolling. So as the ring is rolling, if it is a case that the ring this is smaller, this is R, so this point is instantaneous axis of rotation. This point can be considered as the instantaneous axis of rotation, and in pure rolling the body is said to have pure rotation about the instantaneous axis of rotation. If I consider this point as the instantaneous axis of rotation, then the body is supposed to rotate about this point, pure rotation. So this object is here now. Now after some time it will be here. After some time it will be here. After some time it will be here. So this way the whole thing actually moves. The whole circle moves like that. So it is pure rotation about this point. Otherwise, so to find the kinetic energy of rotation, that is half of I omega square, with what velocity is rotating. Suppose that it is rotating with velocity v here. V is the velocity of this point, center of mass of the sphere, the ring, and what is the omega? Suppose this is the omega about with which it is rotating, because this is the point which is at absolute rest. This point is at rest. So about this point, this whole ring is rotating with, suppose, with a velocity v at this point, and the angular speed is omega. So omega is the angular speed of the center of mass of the ring with respect to this point. Okay. So now if about this point I want to find, suppose this point is P, so this is I about P and omega of P. This point is P. I of P, moment of inertia of this ring about this point will be about this axis and about this axis. We'll use the parallel axis theorem. About this axis is mr square plus m into this distance square, that is mr square. Okay. Now omega p, I'll write just that omega p square. That I have to find out, because that is not given to me. What is given to me is omega naught. That means what I know is the angular velocity of the tip of the finger. So now I have to relate this omega with that omega. What was that omega? Let us draw another diagram to understand what is that omega. I'll draw the same diagram again to understand what is actually happening. This is the center of the ring. This point is the center of the small r. Now you can see that if this rotates with omega, this rotates with omega. This is this point is rotating. This actually is rotating with omega. This point is rotating with omega, and this point is rotating with any other omega. So this omega. But the thing is that by the time just we'll have a fraction of seconds later that this point is actually moving with omega here. This is rotating with omega. So if this point is here and this point is here, this is the line to join them. After a second, when it comes to here, this moves to here, then this whole thing will move to somewhere here. Now this because this when this rotates like that, and this rotates like this, keeps the ring moving. When this rotates, this is changing position, so this point to this point, and this is also rotating, so this will also change position, suppose from here to here. Then you can see that this is the line, this is the path followed by the center. This center will follow this path, okay, and this point will follow this path. This will come inside. This will come inside here, because this point is moving in this way, this point is moving in that way. Now this distance is r, and this distance is r minus r. This distance is r minus r. From here to here, the distance is r minus, because this total distance is the radius r, and this minus this, so this is the distance from this center and its center. So center to center distance is r minus r. You can see that when the point here moves to this point, and this one moves to that point, the angle made is same. It is just like this way. It is, this situation is like this. This angle will remain same. So the velocity here is tangent, velocity is v. Suppose that it rotates with what we have considered this as this is moving with omega naught, this is rotating with omega naught, that we considered. If the angle is same, then their omega is found to be same. This omega has to be same, because if I have a situation like that, if it rotates, then this part will cover less distance, but this part will cover more distance, but still the angle remains same, the angular velocity will remain same. So here this will also rotate with omega, because theta being same. Now v is what? From here I will write that v, the v1, the velocity, this velocity of this is omega naught into r. R is this r minus r. Okay. And if I see this one, then from here, with respect to this point, this is our r. So with respect to this point, v equals to omega into r. This is obtained from here, and this equation is obtained from here. Okay, so you can equate these two, because speed is same in both the cases. V remains same, so equating these two, omega r is omega naught r minus r. So that omega here is omega with respect to p. This is actually omega with respect to p. So omega p is omega naught r minus r divided by r. See, if I put this value here, what I am getting, kinetic energy of the rotating ring is half of, this is 2m square, 2mr square into omega p square, that is this square of this, that is omega naught square, r minus r by r the whole square. So this 2 goes, this mr square, omega square, r minus r the whole square divided by r square. This r square goes, this is m omega naught square, r minus r the whole square. This is the total kinetic energy of the ring. If I see the option m omega naught r minus r whole square, m omega naught square r minus r whole square, so this option number 3 is the correct answer to this question. Okay, thank you.